Hello friends, welcome back to your loving online platform C-Level Physics. My name is Srinivas, known to be BS Rao. Okay, in this lecture, I would like to demonstrate one new physical quantity, that is acceleration. What is meant by acceleration? When do we say that particle possess acceleration? If you want to know, please watch this video thoroughly. Okay, now here see velocity. Velocity, you know very well, velocity is a vector quantity. Why? Because it possesses magnitude as well as direction, and also obeys triangle of addition or parallelogram of addition. So it is vector quantity, means it should have both magnitude as well as direction. Okay. Now any vector said to be changed provided magnitude changes or direction changes, or both magnitude as well as direction changes. Am I right? So similarly here, when do we say that velocity changes, that is change of velocity occurs in three situations? Well, magnitude of velocity changes, or direction of velocity changes, or both magnitude as well as direction of velocity changes. See here, magnitude of velocity may change, direction of velocity may change. In third situation, both magnitude as well as direction of velocity changes. Okay, in all these three situations, velocity of that given particle is said to be changed. Okay, which leads to change of motion. Okay, so in all these three situations, particle said to be possess acceleration. Okay, right? Now let us see what is meant by acceleration. When do we say that particle possess acceleration? Means in all these three situations. Now what is the definition of acceleration? Let us see. When do we say that acceleration means in all these three situations? Coming to definition, we can define as follows. Right? We can define as follows. Acceleration. See, acceleration. That is a bar. Acceleration means it is also vector quantity. Means it should have both magnitude as well as direction. Right? So acceleration. Right? Suppose a particle moves like that. At any instant t1, what is the velocity? 2 meters per second. And at some other instant t2, it is 7 meters per second. At some other instant t3, 15 meters per second, like that. Okay. See here, the magnitude of velocity, as an example, changes. At t1 it is 2 meters per second, at t2 7 meters per second, at t3 15 meters per second, like that, and so on. Okay. Now the change in velocity per unit time is said to be acceleration. Okay. Whatever the change in velocity occurs, that measured per unit time is known as acceleration. So acceleration in the sense, that is acceleration a bar equal to change in velocity per unit time. Change in velocity per unit time. That is time taken to have that change in velocity. Okay. It is a vector quantity. Alright. It is a vector quantity. Means should have both magnitude as well as direction. Okay. Now coming to units, SI unit. What is the SI unit? Change in velocity means again velocity, that is meter per second. So meter per second divided by time also measured in second. So meter per second by second, that is meter per second square. Coming to CGS units, that is centimeter per second. Change in velocity means again velocity, that is centimeter per second in CGS divided by second, that is centimeter per second square. So acceleration measured in centimeter per second square in CGS unit. Am I right? Now it is a vector quantity. Means it follows triangle of addition as well as parallelogram of addition. Okay. Should have direction apart from magnitude also. Right? It is a vector quantity. Now what should be the direction of this vector? Means See here, a bar equal to change in velocity by time. Change in velocity by time. Here time is scalar, but change in velocity is vector. So change in velocity means final velocity minus initial velocity. As velocity possesses direction, so here acceleration also possesses direction. So definitely the direction of acceleration is in the direction of change in velocity. So its direction is in the direction of change in velocity. Change in velocity. Am I right? So its direction is in the direction of change in velocity. Now, what are the types of acceleration here? Here we have average acceleration, instantaneous acceleration, and uniform acceleration, non-uniform acceleration. Different situations. Okay. Let us see, first of all, average acceleration. You know very well, average velocity means total displacement by total time taken to cover that displacement. Average speed means total distance covered upon total time taken to cover that distance. Similarly, here also average acceleration in the sense the total change in velocity upon total time taken to have that change in velocity. So naturally that is average acceleration. Now let us see one by one. One by one. Alright. Okay. Now acceleration means acceleration means a bar. It is divided into two categories. Basically that is average acceleration and second one is instantaneous acceleration. Am I right? Average acceleration, instantaneous acceleration. In general, what is acceleration? That is change in velocity. Change in velocity by time. Change in velocity by time. Right? Now coming to average acceleration. Average acceleration in the sense, see here, suppose at any instant t1, what is the velocity? v1 bar. At some other instant t2, what is the velocity? v2 bar. Okay. Suppose a particle is under motion such that at any instant t1, v1 be the velocity. At some other instant t2, v2 be the velocity. Now what is the time interval here? t2 minus t1. So from here to there, what is the time interval? Delta t, that is t2 minus t1. In that time interval, what is the change in velocity here? Delta v bar, that is v2 bar minus v1 bar. v2 bar minus v1 bar. Otherwise, I am writing somewhere here. So v2 bar here. Here what is delta v bar? Delta v bar equal to v2 bar minus v1 bar. Am I right? Like that. Otherwise, see here, at any instant t, what is the velocity? V bar. At some other instant t plus delta t, what is the velocity? V bar plus delta v bar. Okay. Now see, at an instant t, let v be the velocity. After some interval, from the beginning itself, what is the total time elapsed here? T plus delta t. Okay. At that instant, t plus delta t, what is the velocity? V plus delta v. So during this interval delta t, what is the increase in velocity? See, this is what interval. Within an interval delta t, delta v be the increase in velocity or decrease in velocity, whatever it is. Okay, that is change in velocity, delta v bar. So this is what change in velocity, delta v bar. Now, by definition, average acceleration equal to total change in velocity by total change in velocity divided by total time taken. Total time take care to have that change in velocity. Am I right? That is average acceleration. Average acceleration AVAR equal to total change in velocity. What is the total change in velocity in the time interval delta t here? V2 bar minus V1 bar. V2 bar minus V1 bar divided by what is the time interval to have that change of velocity means delta t, that is T2 minus T1. T2 minus T1. That also equal to delta V. See here, V2 bar minus V1 bar equal delta V bar. See here, what is the change in velocity? Delta V bar. That is what? Delta V bar. Divided by what is the time interval here? T2 minus T1. That itself delta T. In another way, that is delta T. Delta T. See here, delta T is some interval. During that interval, what is the total change in velocity means delta V bar. Okay, so naturally average acceleration means the total change in velocity upon total time taken to have that change in velocity. So usually velocity by time, once again SI it's meter per second by second, that is meter per second square. It is also vector quantity. It is also vector quantity. Should have direction. What is the direction of average acceleration here? Average acceleration means average. We can write like that also. Average acceleration. See this symbol, average acceleration. That is delta V bar by delta T. See here, the direction of average acceleration is in the direction of delta V bar. So its direction is in the direction of delta V bar. Okay, in the direction of delta V bar. One more thing worth note is here average acceleration only depends upon initial velocity and final velocity. See here, V2 bar is final velocity at T2, V1 bar is initial velocity at T1. Okay, so on seeing this expression, average acceleration depends upon initial velocity as well as final velocity, right? It is independent of how the change in velocity occurs during the interval. Okay, see here, most important point. What is that point means? Average acceleration only depends upon initial as well as final velocity, but is independent of change in velocity during the interval. How that change in velocity occurs? Okay, during the interval, it is independent of that factor. Only depends upon initial as well as final velocity. So it is only depends. It only depends. Only depends initial and final velocities, and is independent of how the change of that velocity occurs during the interval. Okay, it doesn't depend upon that factor, right? Now coming to instantaneous acceleration. See here, during the large interval we have large change in velocity, whether it is increase in velocity or decrease in velocity. Am I right? So during the large interval we have large change in velocity. Suppose if we minimize that total time interval like that, eventually we reach one instant. Okay, if large time interval reduces to minimize like that, now eventually we reach a fraction of a second, or otherwise 1/10 of a second, otherwise 1/100th of a second, otherwise 1,000th of a second. Means eventually if total time interval reduces to decrease to have instant. Now if we measure that change in velocity, especially in that eventually reaching instant, then that becomes instantaneous acceleration. Okay, that is A bar instantaneous equal to dV bar by dt, not delta V bar by delta t. It is dV bar by dt. Dt means it's not the interval. In fact, that is fraction of a second. Fraction means it may be 1/10th or 100th or 1,000th second. Right? So at that instant, let dv bar be the change, a small change in velocity occurring. That small change in velocity upon that instant gives instantaneous acceleration. Here, we only measures small change in velocity in that small instant. Am I right? We are not going during entire interval. Okay, during that interval, our interest is to measure the change in velocity, especially at some instant. That's all. So if you measure like that, then that kind of acceleration is said to be instantaneous acceleration. See here. See here. What about delta v bar by delta t? Delta v bar by delta t is nothing but delta v bar by delta t is nothing but average acceleration, right? Now, if I write one limitation here, one limitation, see, one limitation, what is that limitation? Delta t tends to 0. If you reduce large time interval, that is delta t approaches to 0, but not equal to 0, in fact not equal to 0, but reduces to 0 means we are minimizing time interval to have one instant. So with this limitation, delta v bar by delta t becomes dv bar by dt. dv bar by dt. That's so delta t becomes dt, delta v bar becomes dv bar. That's all. Okay, right? When delta t approaches to 0, delta t becomes dt. Means large interval reduces to instant. Large change in velocity reduces to small change in velocity. Now, that small change in velocity per at any instant becomes equal to instantaneous acceleration. That is a bar instantaneous. Instantaneous. A bar instantaneous. Am I right? Okay. Now, what about the direction of instantaneous acceleration? Of course, it is also vector quantity. It is also vector quantity whose accelerates are meter per second by second, that is meter per second square. Once again, so whatever the kind of acceleration, all are having same S units, so same CGS units, etc. So all are vector quantities only, means all are having direction apart from magnitude and obeying triangle. The direction of instantaneous acceleration is in the direction of dv bar. That is dv bar means the whatever the direction of change in velocity at that instant, that itself the direction of instantaneous acceleration. Alright. So always a bar is in the direction of dv bar. That's all. Now if I take scalar notation, that is magnitude only, then a instantaneous equal to dv by dt. dv by dt. That equal to d by dt of t by dt of what about v, that is dx by dt or ds by dt or dr by dt, etc. Okay, v means ds by dt as an example, right? Velocity means, of course, you can write dv bar by dt or ds bar by dt here. I am not interested in writing bar. So that is a instant equal dv by dt, that is d by dt of v. V means ds by dt. Otherwise dx by dt, otherwise dr by dt, etc. For the sake of convenience, okay, we can write any argument in case of displacement, yes, or r or otherwise x, etc. That is d square s by dt square, d square s by dt square. That is second derivative of displacement with respect to time, also known as instantaneous acceleration. Am I right? So that itself we can write a instantaneous equal to dv by dt, that equal to d square s by dt square, that equal d square x by dt square, otherwise d square r by dt square. Right? The rate of change of position, x means dx by dt means the rate of change of ds by dt means the rate of change of displacement, dx by dt means the rate of change of position, dr by dt means the rate of change of position vector. So in different situations we can write in different ways. Am I right? So a instantaneous equal to either dv by dt or d square s by dt square or d square x by dt square, otherwise d square r by dt square. One more rule, that is chain rule. See, a instantaneous equal to dv by dt. dv by dt multiplied and divided by ds. See, a bar equal to dv bar by dt, otherwise a equal to dv by dt. Here a small modification, that is multiplied and divided by ds, right? That is dv by ds, dv by ds, dv by ds into ds by dt, into ds by dt. Shall we write or not? Yes. A instantaneous equal to dv by dt multiplied by ds by ds. So on cancelling both, what happens? We left with the dv by dt one. Okay, nothing wrong by taking like that. So here dv by ds is one term, ds by dt is another term. That is ds by dt in the sense that is v. So ds by dt means v. v into dv by ds. So A instantaneous equal to v into dv by ds. Okay. Otherwise v into dv by dx also, as per the situation. Am I right? As per the situation. That is v into dv by dx also. That is v into dv by dr also. dr also, as per the situation. Okay, this is what chain rule. So for acceleration, we can have many formulas. That is a equal to either dv by dt, otherwise d square s by dt square, otherwise v into dv by ds. Okay, so like that, in many ways we can have expressions for acceleration. Am I right? Now coming to numericals, different numericals. Let us check one by one. Okay, here a particle moving at 5 meters per second eastwards. Okay, in 10 seconds the velocity changes to 5 meters per second northwards. Find the average acceleration in this time interval. Am I right? See here, the magnitude of velocity remains same. No change in magnitude of velocity, but direction only changes here, from eastward to northward. Am I right? Now, first of all, I am taking one plane like that, one plane like that, containing geographical directions. This is what north, this is what south, this is what east, this is what west. Am I right? What is angle between north and east? 90. Between east and south also 90. Between south and west also 90. Between west and north also 90 degrees. Am I right? So this is the plane containing all the directions as shown. Right? So this is what x-axis, this is what y-axis, this is what negative x, this is what negative y. This is what this is what positive z, this is what negative z like that. Am I right? Now see here, magnitude of velocity only changes. First of all, see the direction of initial velocity. Particle moving at 5 meters per second eastwards. East means like that. So once again I am writing plane. Okay, eastwards. See, this is what origin. Say this is what origin. Right? From this origin, particle moving due east, let it be v1 bar of magnitude 5 meters per second. Right? From which, what is the direction of velocity? Northwards. North means this is what east, this is what north. Of course, this is the direction of motion. Now, I am shifting this direction of motion, this vector parallel to itself and joining somewhere here. Nothing wrong by doing like that. Am I right? So, in fact, particle moves initially due east and again due north. So, this v2 bar, final velocity v2 bar is shifted parallel to itself and joining at origin without changing its orientation. Am I right? So, this is what final velocity v2 bar. Right? So, v1 bar, v2 bar. Now, what is the meaning of average acceleration? Average acceleration in the sense total change in velocity by total time taken to have that change. Am I right? So, total change in velocity. Change in velocity means v2 bar minus v1 bar. See here, average acceleration. Average acceleration means total change in velocity by total time taken. That is delta v bar means v2 bar minus v1 bar by t. So here, before finding average acceleration, we need to find change in velocity. What is change in velocity? V2 bar minus V1 bar. So V2 bar minus V1 bar means V2 bar minus V1 bar means V2 bar plus or minus V1 bar. V2 bar plus or minus V1 bar means subtraction vector. Subtract V1 from V2. Indirectly, that is one kind of addition. That is adding minus V1 bar to V2 bar. That's all. So V2 bar as usual. Now make it reverse V1 bar. This is what? Minus V1 bar. Minus V1 bar. If it is V1 bar, definitely this is minus V1. See the direction, minus V1 bar. Make it reverse. Alright? Now add this minus V1 bar to V2 bar. See, this is what minus V1 bar, this is what V2 bar. Now these two are parent vectors for the time being. Now close the parallelogram. Close the parallelogram such that one side parallel to minus V1 bar, one side parallel to V2 bar, right? These two vectors are adjacent sides of parallelogram, both in magnitude and direction. Okay, drawing from the same point, then a diagonal drawn from the same point, common point is the result. Now this is what? V2 bar plus or minus V1 bar, that is delta V bar. Delta V bar means V2 bar plus or minus V bar. This is the delta V. Alright? Now what is delta? That is delta V bar equal to V2 bar minus V bar. Of course, these two are of same magnitude, 5 meters per second, 5 meters per second. So V1 bar equal to mod V1 bar equal to mod V2 bar equal to V, that is 5 meters per second. V, that is 5 meters per second. When P equal to Q, what is the magnitude of difference here? See, is this difference or sum? Difference. In case of when P equal to Q, what is the difference of 2P sin theta by 2? Otherwise, 2Q sin theta by 2. Am I right? So, in the same way, when V1 equal to V2, what is the difference? Delta V equal to 2V sin theta by 2. 2V sin theta. So, take the magnitude here. The mod delta V bar, that is delta V equal to 2V sin theta by 2. That is 2 into, what is V here? Both are of same magnitude. What is the V? That is 5 meters per second. 2 into 5 into sin theta. What is the angle between V2 and minus V1 bar? 90 degrees. 90 degrees. 90 by 2. So sin 90 by 2 means 45. Sin 45. Sin 45, that is 1 by root 2. Alright. 2 5 is 10 into 1 by root 2. 10 by root 2. 10 by root 2. Right. 10 by root 2 meters per second. Right. In vector notation, 10 by root 2 delta V bar equal to 10 by root 2 meters per second. In vector notation, assign the direction of delta V bar here. As these two are of same magnitude, right? Resultant bisects the plane. Bisects means here 45 degrees, here also 45 degrees. 45, 45. Why? Because resultant always close to that vector whose magnitude is more. But here both are of same magnitude. Definitely resultant bisects the plane. So this is what north. This is what west. Therefore this is northwest. Northwest. So resultant, that is delta V bar, that is V2 bar minus V1 bar, lying due northwest. 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 Am I right? In case of direction, northwest. Okay, we have change in velocity. So average acceleration equal to that is change in velocity means 10 meters per second, 10 by root 2 meter per second divided by time. What is the time? Given time interval, that is 10 seconds. 10 seconds. So 10 seconds. That is 10 cancel here. We left with 1 by root 2 meter by second, meter per second square. Meter per second square. Okay. So this is what average acceleration. In case of direction, So average acceleration in vector notation, that is equal to 1 by root 2 meter per second square. 1 by root 2 meter per second square. What is the direction? The direction of average acceleration is in the direction of change in velocity. What is the direction of change in velocity? That is due northwest. So average acceleration direction also northwest. Northwest. Right? So that's how one can find the direction of average acceleration. Am I right? Coming to next numerical. Suppose coming to next numerical. Here see the relations. V equal ds by dt. Now from which ds equal v dt. That is integral ds equal integral v dt. Suppose rate of change of position is velocity. From which ds equal v dt means within interval dt, what is the displacement covered ds? Okay, within instant dt, displacement covered is ds. Within a large interval, what is the total displacement covered means we have to take summation. That can be done by integration. Integration means addition of all small ds in this case. So in every dt, displacement ds. In a time interval delta t, definitely such kind of ds must be added. That is integral ds means addition of all ds values. So integral ds means yes, integral v dt. So like now coming to acceleration, a equal dv by dt means rate of change of velocity is acceleration. From which dv equal a dt. dv equal a dt means at any instant dt, what is the change in speed or change in velocity dv. Okay. In a total time interval, what is the total change in velocity? Integral dv, that is integral a dt. If you want to get the total change or total value, then you must go with integration. Right? That is integral dv equal integral a dt. Integral dv means v, that total change in velocity, v or delta. Okay. Now one more relation for acceleration, that is a equal d square s by dt square. Okay. Second derivative of position or displacement with respect to time, also known as acceleration. That is a equal one more relation, v into dv by ds, chain rule, v into dv by ds. Now see from which we can observe like that. ds by dt equal v, dv by dt equal a means differentiation from s to v or v to a, differentiation means on differentiating s with respect to time we can get v. On differentiating v with respect to time we can get acceleration. Okay. So from left to right, this point is s v a. From left to right, okay, we can get the next quantity on differentiating previous quantity like that. Now coming to reverse direction from a to v. How to get v from a means, see how to get v from a means by integration. Integral dv equal to a dt. So that is v equal integral a dt. So v equal to integral a dt. Similarly, s equal to integral v dt. S equal integral v dt. So if you go, we get the next quantity from the previous quantity in the reverse direction. If you want to get v from a means take integral a dt, then you will get v. If you want to get s from v means take integral v dt to get s. Okay, from left to right differentiation, from right to left integration like. Okay. Now coming to numerical. If s equal tq minus 6t square, s is what? Displacement. Variation of displacement with respect to time is as shown. Now find the acceleration when body is at rest. When body is at rest means velocity becomes 0. Now how to get velocity from this expression? See, s equal to tq minus 6t square. Now what is velocity? Velocity means ds by dt. Take differentiation, that's all. Differentiation. That is ds by dt. V equal to ds by dt. That is, how to get v? How will you get v on taking differentiation? S with respect to time. So v equal ds by dt. That is d by dt of tq minus 6t square. Now what is the general expression? Integral d by dx of x power n equal to n into x power n minus 1. So in the same way, find here. So v equal to d by dt of t cube, d by dt of t cube, d by dt of t cube minus 6 is common, 6 into d by dt of t square. Now take this relation into consideration, that is d by dx of x power n into x power n minus 1. Alright. Now d by dt of t power 3 means 3 into t power 3 minus 1. That's n into x power n minus 1. The same. Minus 6 into, see here, what is n? 2. 2 into x power, n into x power n minus 1. That is 2 into x means here t. Power n minus 1, n minus 1. That is 2 minus 1. That is 3t square minus 6 2 12 t. 12t, that's. So v equal to so and so. V equal to so and so. Now, when will this velocity become 0? Means if v equal to 3t square minus 12t equal to 0. See, we have to find acceleration when body is at rest. When body is at rest, definitely this velocity must be 0. Now, when that happens, let us check. Now 3t is common here. 3t of t minus 4. That's 3 minus 4 equals. So 3 never be equal to 0. Definitely t equal to 0. Otherwise t minus 4 equals. That is t equal to 0. Otherwise t equal to 4 seconds. So t equal to 0 means when our observation starts. So initially particle is at rest. Once again it comes to rest at on completion of 4th seconds. Now we need to find acceleration when body is at rest. Means now see the expression for acceleration means this is what number 1. 1 implies how to get acceleration from velocity by differentiating velocity with respect to time. You can have acceleration. Coming to acceleration, how to get acceleration? A equal to dv by dt. See, this is what expression for velocity. 1 implies A equal to dv by dt. That is d by dt of 3t square minus 12. 3t square minus 12t. That is 3 into d by dt of t square means 2t from this relation. 2t minus 12 is constant. D by dt of t means 1. 1. So A equal to, what is the expression? 60 minus 12. 6t minus 12. Now we need to find acceleration when it comes to rest. Means it happens twice, initially and after 4 seconds. So we need to find acceleration at t equal to 0 equal to 6 into 0 minus 12. That is minus 12 meter per second square. Next, acceleration at t equal to 4 seconds. That is equal to 6 into 4 minus 12. That is 24 minus 12. 12 meter per second square. Okay. Right? So that's how one can find acceleration. 2 accelerations. Initially and after 4 seconds. Okay. Now let us see next numerical. Am I right? Okay. Next numerical, that is, this time you are given expression for displacement which is changing with time as shown. That is s bar equal to 3ti plus 4tj. Find velocity, speed, acceleration at t equal to 2 seconds. See, this is what variation of displacement with respect to time. Right? That is s bar equal to 3ti cap plus 4tj cap. This is what sx. This is what sy. So displacement, x component of displacement 3t, y component of displacement 4t. Right? Now, on differentiating sx with respect to time, we can have vx. On differentiating sy with respect to time, we can have v1. So vx equal to dsx by dt. See, what is v here? V means ds by dt. Vx equal to dsx by dt. Suffix dsx. That is d by dt of sx. What is sx? 3. That is 3 into dt by dt means 1. That is 3. 3 meter per second. Okay. See, this is in meters as an example. Meter. Displacement expressed in terms of meters. Now coming to Vy. How to get Vy equal to dsy by dt. Y coordinate of velocity equal to differentiation of y coordinate of displacement with respect to time. That is d by dt of what is sy? Sy means here 4t. 4. That is 4 is common. 4 into dt by dt means 1. That is 4 bit plus. Now V bar equal to Vx into I cap plus Vy into j cap. That is 3I cap plus 4j cap. Meter per second. Meter per second. Now see, in this expression, we came to know that velocity is independent of time. No time involved in this expression. There is no time involvement in this expression. Means velocity is constant. Both x component as well as y component of velocity constant. Not changing with respect to time. Therefore, mod V bar means root over Vx square plus Vy square. That is root over 3 square plus 4 square. That is root 9 plus 16 means root 25. Root 25 means 5. 5 meter per second. 5 meter per second. What is modulus of V bar? Magnitude of velocity. Magnitude of velocity. Right? Magnitude of velocity. What is the other name for magnitude of velocity? Speed. So both are of same quantity. Velocity or speed means 5 meter per second. Therefore, velocity equal to speed equal to 5 meter per second. Right. Coming to acceleration. Acceleration means how to get acceleration? A equal dv by dt. That is dv by dt. d by dt of v. V means what is v? 3i plus 4j. That is 3i plus 4j. Okay. 3i plus 4j means there is no time involvement. 3 is constant, 4 is constant. That is 0 plus 0. X component of acceleration 0, y component of acceleration also 0. That is 0. So ax 0, ay 0 implies mod a bar also 0. Net acceleration also 0. Am I right? So now let us see one more numerical. Okay. Right? Now in this sum, the position of a particle as a function of time t is given by x of t equal to a t plus b t square minus c t, where a, b, c are constants. When particle attains zero acceleration, its velocity will be. Now we have position of particle with respect to time. Right? This is what position of particle x of t equal to a t plus b t square minus c t, where a, b, c are constants from data. This is what expression for position, which changes with the time as follows. Now, when particle attains zero acceleration, find its velocity. We need to find velocity of particle by the time when its acceleration becomes 0. Now, how to get acceleration means on differentiating position with respect to time, we can have velocity. Okay, on differentiating velocity with respect to time, we can have acceleration. So, we need to find differentiation of x with respect to time. So, v equal to dx by dt. Say this is x, dx by dt. That is d by dt of at plus bt square minus ct. That is a into dt by dt plus b into d by dt of t square minus c into d by dt of t cube. That is a into dt by dt 1, a plus b into d by dt of t square means 2t minus c into d by dt of t cube means 3t square. Since d by dx of x power n equal to n into x power n minus 1. So making use of this relation, we can find d by dt of t square means what is n here? 2. So 2 into t power 2 minus 1, that is 2t. Here 3 into t power 3 minus 1, that is 3t square. Like that. So this is what velocity. Right? velocity. Number 1. Now differentiating velocity with respect to time. 1 implies A equal to dv by dt. dv by dt. That is d by dt of v. v means A plus 2bt minus 3ct square. That is A equal to d by dt of A. A means what? Constant. So 0. There is no change in A with respect to time. 0 plus 2b constant. D by dt of t means 1 minus 3c constant. D by dt of t square. D by dt of t square means 2 into t power 2 minus 1. That is 2t. 2t. Correct? That is 2b minus 6t. 6ct. 2b minus 6ct. Now, what is the condition here when particle attains zero acceleration? If A equal to 2b minus 6t equal 0 implies 2b equal to 6t implies t equal to b by 3. T equal to 6ct, sorry, 6ct here. ct. Now 6ct here. That is t equal to b by 3c. b by 3c. Now this is what time? This is the time at which acceleration becomes 0. Now eliminate t in velocity expression with the b by 3c. That's all. Now let us see what is the velocity here. Velocity somewhere here. Now I am writing somewhere here. We need to find velocity by that time when it attains zero acceleration. This is the time when velocity becomes 0. Right? So v of t, which is equal to b by 3c, equal to, what is the velocity here? Sorry, what is the velocity here? A plus 2bt minus 3c t square. 3c t square. Right? Now velocity at t equal to b by 3c equal to a plus 2b into t. T means what? b by 3c. b by 3c minus 3c into t square. T square means b by 3c whole square. That is equal to a plus b by 3c 2b okay, a plus 2b square by 3c minus 3c gets cancelled. We left with the b square by 3c. That is a plus 3c is common here. That is 3c LCM. 2b square minus b square. That is b square. So this is what velocity at t equal b by 3c. Am I right? A plus b square by 3c. Right? Okay. Now coming to one more numerical. Right? Okay. Now, if instantaneous velocity of a particle v equal to 5 times e power t meter per second, find average acceleration, average velocity of particle between instants t1 equal to 2 seconds to t2 equal to 4 seconds. Here we have expression for velocity, that is v equal to 5 times e power t, right? 5 times exponential power t, e power t meter per second. Now, average, we need to find average acceleration, average velocity. A particle between instants t1 equal to 4 seconds. What is average acceleration? Total change in velocity by total time taken. Total change between 2 to 4 seconds. So, v of 2 equal to v of 2 equal to v of 2 means velocity at 2 seconds. That is 5 into e power 2. Similarly, v of 4, velocity at 4 seconds, that is 5 into e power 4. Replace t by writing 4. This is what initial velocity v1, this is what final velocity v2. Now, what is average acceleration? Average acceleration equal to delta v by delta t. That is v2 minus v1 by t2 minus t. Right? In scalar notation, I am not writing arrow, right? That is v2 means 5. v2 means 5 e power 4 minus v1 means 5 e power square divided by t2 minus t. This is the velocity at instant t equal to, this is the velocity at the instant 4. Now what is the interval between these two? 4 minus 2. 4 minus 2. That is 4 minus 2. That is average acceleration equal to 5 e power 2 is common. 5 e square is common. We left with e square here minus 1 by 2. This is the average acceleration. Now coming to average velocity. Average velocity in the sense total displacement upon total time taken to have that displacement. What is the total displacement? Not there here. So we need to convert this expression in terms of displacement. So v equal to dx by dt implies dx equal to v dt. Implies, this means in any instant dt, what is the displacement covered dx? In a time interval, some time interval, what is the total change in position of total displacement means? How can we get that value means? By integration. That is integral dx equal to integral v dt. Right? dx equal to integral v dt. Here s is there, but here x is there. For the sake of convenience, you can have any alphabet. So s equal integral v dt here. X equal to integral dx means x or delta x. So x equal to integral dx, that is x, equal to integral v dt. What is the expression for velocity? Integral 5 times e power t. Now what are the limitations here? Lower limit 0, upper limit 2 seconds for example. That means to say that this is the displacement from 0 to 2 seconds, that is in first 2 seconds. Right? That is x1 for example. That is 5 is constant. Integral e power t into dt now. So dt also there here. dt. That is 5 is common. Kept outside. Integral e power t dt means e power t1. E power t1. That is the solution. Integral e power x dx equal to e power x. Integral e power t dt equal to e power t. Now limits 0 to 2. 0 to 2. That is x1 equal to 5 into, replace t by writing upper limit e square e power t means 2 here minus, now this time lower limit instead of t, that is what is the lower limit? 0, e power 0. That is e power 0 means 1, that is 5 times e square minus 1. Similarly, this is what displacement covered in first 2 seconds, right? X of 2, that is x1. Similarly, you can find displacement covered in first 4 seconds. First 4 seconds means x2 equal to integral v dt. Once again same relation, x2 equal to integral v dt, integral 5 times e power t dt. Now what are the limitations? 0 to 4 seconds this time. This is what displacement covered in first 4 seconds. This is what displacement covered in first 2 seconds. That is 5 times integral e power t dt means e power t only. What are the limits? 0 to 4. 0 to 4. Right? Otherwise, we can take limitations here. 0 to 2, similarly 0 to 4. No need to write everything here. Right? That is 5 into e power t means 4 e power 4 minus lower limit e power t means 0. That is e power 0. That is e power 0 means 1. 5 times e power 4 minus 1. Right? So this is what displacement covered in first 2 seconds. This is what displacement covered in first 4 seconds. But question is to find average velocity between 2 to 4 seconds. Right? 2 to 4 seconds means displacement covered in first 4 seconds minus displacement covered in first 2 seconds gives displacement covered from 2 to 4 seconds. Okay? 2 to 4 seconds. I am writing somewhere here. Right? Now x of 2 displacement covered from 2 to 4 seconds. Suppose this is what displacement covered from t equal to 0 to t equal to 4 seconds. What is that value? 5 into e power 4 minus 1. Now from 0 to 2 seconds, this is what t equal to 2 seconds. Okay, from t equal to 0 to t equal to, what is the displacement covered here? 5 into e square minus 1. So from here to there, 5 times e power 4 minus 1. From here to there, 5 times e square minus 1. Now displacement covered from 2 to 4 seconds means this value minus this value. So this is what delta x. Okay, from 0 to 4 seconds, this is the displacement. From 0 to 2 seconds, this is the displacement. From 2 to 4 seconds, this one minus this one. That is delta x. So delta x equal to 5 times e power 4 minus 1 minus 5 times so e square minus 1. That is 5 times e power 4 minus 5 times e square plus minus 7 plus 5. So minus 5 plus 5 cancel. Here 5e square is common. 5e square of e square minus 1. So this is what displacement covered from 2 to 4 seconds. 2 to 4 seconds. Right? Now average velocity equal to delta x by delta t. That is x2 minus x1 by t2 minus t1. x2 minus x1 means delta x. This is the x2 minus x1. That is 5 times e square into e square minus 1 by delta t. That is t2 minus t1 means 4 minus 2. What is the interval between these two? 4 minus 2. 4 minus 2. So answer is v equal to 5 by 2. 4 minus 2 means 2. 5 by 2 e square of e square minus 4. So this is the average velocity. This is the average velocity from t equal to 2 seconds to 4 seconds. Okay. Now say here one more sum. If a car accelerates with the acceleration depends on displacement as acceleration equal to 6x square plus 2x plus 5. So this is what variation of acceleration with respect to position. X means position or displacement. A means acceleration. Find velocity of particle when it is at x equal to 3 meters. We need to find velocity of particle when it lies at x equal to 3 from the option. Alright. So here one notation is there, that is initially it starts from x equal to 1 with u equal to meters per second. What is initial velocity? U equal to meter per second. Right? It starts from x equal to 1 when its velocity u equal to meter per second. Right? Now say a equal to 6x square plus 2x plus 5. From which we must find velocity of particle when it is at x equal to 3. Means variation of, what is the relation between a and x? A and x or a and s. See somewhere there. A and s. A equal to v into dv by ds. A equal to v into dv by ds. Now take that formula into consideration. A equal to v into dv by chain rule dv by ds, otherwise dx. Here x is there, so change that alternate s by writing x. v into dv by dx implies dv equal to a equal v into dv by dx. Okay, now v into dv equal a dx, a into dx. Now see this relation saying that in a small displacement dx, what is the change in velocity dv? Okay, right? If you want to get large change in velocity in covering large displacement, that can be done by integration. Okay, now integral v dv equal to integral a dx, okay, integral v dv equal to integral a dx. Now what are the limits? What is the initial position of particle x equal 1? X equal to 1, right? Final position. What is the final position? X equal to 3. That is x equal to 3. These are the limits. When x equal to 1, what is the velocity? When x equal to 1, what is the velocity 2? So when x equal to 1, velocity equal to 2. When x equal to 3, we need to find velocity, that is unknown. Alright. So x equal to 1 means velocity is 2. X equal to 3 means velocity is unknown. That is v. So these are the limitations. So integral v dv. What is the relation? Integral x power n dx equal to x power n plus 1 by n plus 1. This is the relation, general relation. Now, as far as that formula is concerned, v power n means what here? 1 1. So x power n plus 1 by n plus 1 means v power 1 plus 1 by 1 plus 1. Limits 2 to v. That equal to, what is a here? Integral x equal to 1 to x equal to 3. Integral a dx. A means 6x square plus 2x plus 5 whole into dx. That is v square by 2. V square by 2 limits 2 to v. That equal to 6 is constant. Integral x square dx, 6 into integral x square dx, distribute with the dx throughout the terms here. 6 into x square dx, x square dx means x power 2 plus 1 by 2 plus 1, that is x cube by 3. What are the limits here? 1 to 3. Similarly, 2 is constant. Integral x dx means x power 1 plus 1 by 1 plus 1. X square by 2. Limits 1 to 3. Plus 5 into integral dx means x. Integral 5 into integral dx means x. Limits 1 to 3. That is upper limit. What is upper limit? V only. Lower limit 2. That is v square by 2. V square by 2 minus 2 square by 2. 2 square by 2 equal to 6 by 3 means what here? 2 into 6 by 3 2. X cube. What are the limits? 1 to 3. That is 3 cube minus 1 cube plus 2 by 2. 2 by 2 means 1. That is we left with x square. That is 3 square minus 1 square. Plus 5 into x means here 3. Again x means 1. 3 minus 1. Upper limit minus lower limit every time. Okay. Now I am writing somewhere here. Okay. That is, see the continuation. V square minus 4 by 2. V square minus 4 by 2 equal to 3 cube means 27. 2 into 27 minus 1, that is 26. Plus 3 square means 9. 9 minus 1, that is 8. Plus 5 into 3 minus 1 means 2. 2 into 5, 10. That is v square minus 4 by 2 equal to 2 into 26, that is 52 plus 52 plus 52 plus 8, that is 60, 60 plus 10, 70. That is v square minus 4 equal 2 into 70, 140. V square equal 140 plus 4, that is 144. Alright? V square equal 140 plus 4. That is v equal to root 144. That is v equal to, what is v? 12 meter per second. 12 meter per second. Okay? Right?